Okay, so we have the sequence of partial sums. This is a key definition. Take your time and digest that. Okay, because we're going to be coming back to it over and over and over again. Let's zoom out a little bit here so I can write below it without erasing it. Okay. Now, our next definition is the main one. Okay, we're going to say, whoopsie daisy, black. I want my black color. Okay, definition. So what do we mean when we say a series converges? Okay, we're adding an infinity of numbers. Okay, as we saw with Zeno, it could add up to a number, right? So what do we mean? We want to make that precise. So here we go. We're going to use the sequence of partial sums. So if Sn converges, as a sequence, then we say that summation an is convergent. So that's what we mean by a convergent series. Okay. If the sequence of partial sums converges. Okay, and if it doesn't converge, okay, otherwise, summation an is said to be divergent. Okay, so the sequence of partial sums converges. So what do we mean there? We mean that limits of Sn as n goes to infinity equals, some real number, L. So it's all getting kind of mixed together, okay? You have the idea of a sequence, you have the idea of a series, and if you want to talk about the convergence of a series, then it turns out, well, at least with our approach, you're going to be talking about, we're going to be investigating the convergence of some corresponding sequence. Okay, all very theoretical so far. Why don't we look at a example? So show that summation negative. Come on. Come on. My tablet is freezing. So I want to show that this diverges. Okay, so we have a1 is equal to negative 1 to the 1, which is negative 1. Negative 2 is negative 1 squared, it's equal to 1. And so on and so forth. Okay, so what do we get? S1 is equal to just a1, which is negative 1. S2 is equal to a1 plus a2, which is equal to -1 plus 1, which is 0. S3 is equal to a1 plus a2 plus a3, which is going to equal -1 again. So it looks like, S16 is going to equal, because it's even 0, S177 is going to equal -1. So what do we say about the sequence? Okay, so the sequence Sn is the sequence -1, 0, -1, 0, -1, 0, -1, 0. Now, is the sequence approaching anything? No, it's not. Okay, so it's divergent. So therefore, by def given above, summation -1 to the n is divergent as well. Okay, so we had a series. We looked at its sequence of partial sums. That sequence was divergent, and that tells us, by the definition, you may want to review that. By definition, if that sequence of partial sums is divergent, then the series itself, up top here, which I'm circling, is divergent.